Welcome to this video series of the Python course. In the previous videos, we got an overview of Python libraries and we also discussed about the NumPy and Pandas library in Python. In today's video, we will discuss about the Matplotlib library in Python. So, Matplotlib is a powerful Python library used for creating static, interactive, and animated visualizations in Python. This slide emphasizes the importance of Matplotlib in data visualization, highlighting its role in facilitating data exploration, communication, and decision-making through visually compelling plots and charts. Importance of Matplotlib. Matplotlib helps convey data insights clearly through visual plots. It supports various plot types, customization, and interactive features. Matplotlib creates polished, customizable plots ideal for presentations and reports, ensuring professional and visually appealing results with high quality outputs. It aids in exploring data visually to spot patterns and anomalies. It allows users to quickly detect outliers and understand distributions, aiding in informed decision making and effective communication of findings. It works seamlessly with other Python libraries for efficient data analysis. Integration with libraries like NumPy and Pandas enhances its functionality, transforming complex data into clear visual formats for effective communication. Plotting X and Y points. We use the plot function from Matplotlib pyplot module for plotting XY points. Most of the Matplotlib utilities lies under the pyplot submodule and are usually imported under the PLT alias. Here's a basic example. So, using the matplotlib.pyplot submodule, we can plot XY points. First, we create two lists of X and Y points, and then we use the plot function to plot these points. On executing this code, this is the result that we will get on our screen. With pyplot, we can also use the X label and Y label functions to set a label for the X and Y axis. We add a title to the plot using plt.title. Finally, we display the plot using plt.show. Customizing plots. Matplotlib allows for extensive customization of plot appearance to enhance clarity and visual appeal. So here, color equal red. This parameter specifies the color of the line in the plot. Here it's set to red, indicating that the line will be drawn in red color. You can use various color names like blue, green. Marker O. This parameter determines the marker style used to denote each data point on the plot. O represents circular mark. Other marker styles include S for squares and this symbol for triangles, etc. Line style. Line style. This parameter sets the line style for the plot. Double hash indicates a dashed line style. Other line styles include this symbol for solid lines and semicolon for dotted lines, etc. Creating scattering plots. Creating scattering plots in Matplotlib is straightforward by using the plt.scatter function. So, we will use the plt.scatter function, and inside the function we'll mention the xy points and then we can customize it accordingly. On executing this code, we'll get this scatter plot on our screen. Here, S equals sizes sets the size of each marker based on the sizes list. C equal color sets the color of each marker based on the colors list. Marker O specifies the style of the marker. In this case here it is circles. Alpha equals 0.5 sets the transparency level of these markers. 0 means fully transparent and 1 is fully opaque. Creating bar graphs. So by using the plt.bar function we can create bar graphs. Similarly, the categories, values, color, edge and width are different parameters used for customizing bar graphs. Categories is a list containing the labels for the x-axis and values is a list containing the corresponding values for each category. Color equals sky blue. This parameter sets the colors of the bar to sky blue. Edge color equal black. This parameter adds a black border around each bar. And width equals 0.6. This parameter sets the width of each bar to 0.6 unit. The default is 0.8. Horizontal bar graphs. If we want the bars to be displayed horizontally instead of vertically, we can use the bar edge function. So, inside the bar edge function, we mention the categories and values and we can customize the bar graph accordingly. On executing this code, we'll get horizontal bar graph on our screen. This code creates a horizontal bar graph with the specified customization option. Creating histograms in Matplotlib is straightforward by using the plt.hist function. So inside the hist function, we mention the data, and after that we can customize the histogram accordingly. So on executing this code, we'll get this histogram on our screen. Here, np.random.random1000, this function generates 1000 random data points from a standard normal distribution. Bins equal 20 specifies that the data should be divided into 20 bins, which means intervals. Sky blue, this sets the color of the bars to sky blue. Edge color parameter adds a black border around each bar, and alpha equals 0.7 sets the transparency level of the bars. 0 means fully transparent and 1 is fully opaque as mentioned earlier. Creating pie charts. Pie charts are created using Matplotlib by using the plt.py function. So just like other graphs, inside the plt.py function, we mention the labels and sizes, and then we can customize this pie chart accordingly. So on executing this code, this is the pie chart that we get on our screen. Here, the explode parameter allows you to visually emphasize specific slices by separating them from the center of the pie chart. Explode 0,0.100 specifies the fraction of radius with which to offset each slice. Here the second slice B is exploded from the rest. Colors sky blue, light green, light coded orange set the color for each pie slice, and start angle sets the angle at which first slice starts, counterclockwise from the x-axis. PLT axis equal, this parameter sets equal aspect ratio to ensure the pie is drawn as a circle. Now we will go to the Google Collab platform where we will see some practical application of what we have learned today. So now we are at Google Collab, and let's begin with an example on how to plot XY points. So first we will define two lists X and Y that will hold the X and Y points respectively, and after that we will use the plot function to plot these points. The function xLabel and yLabel can be used to give a title to the x-axis and y-axis. If we'll execute this code, this is the graph that will be printed on our screen. Now we will see how can we customize these plots. So inside the plot function, we can use the parameters color, marker, line style, and label to customize these plots. If we'll execute this code, we can see that a customized plot is printed on our screen. Coming to how to create scatter plot. So similarly, we'll use a plt.scatter function inside which we'll define x and y, and s equal sizes, c equal colors, marker, and alpha are the parameters that we can use to customize these plots. If we'll execute this code, this is the scatter plot that we get on our screen. Creating bar graph. So for creating bar graphs, we will use the plt.bar function. Categories and values are two lists that are defined, and then we can use the parameters color, edge color, and width to customize this plot. On executing this code, this is the bar graph that we get on our screen. We can see that the categories A, B, C, D, E are printed in this scatter plot as well, in this bar graph as well. Creating horizontal bar graph. So for creating horizontal bar graph, we use the bar edge function, and the remaining parameters will remain same as the bar function. If we execute this code, we'll get a horizontal bar graph on our screen. Now coming to how to create histograms. So we'll use the np.random.random function to get 1000 random values, and we'll use these values to plot the histogram. We'll use the plt.hist function and then the parameters bins, color, edge color, and alpha to customize our plot. If we'll execute our code, this is the histogram that we'll get on our screen. Finally, coming to how to create pie charts. So sizes and labels are the two lists that we'll create first for our pie chart, and then we'll use the plt.py function inside which we'll use colors, explode, and start angles as parameters to customize our pie chart. If we'll execute this code, this is the customized pie chart we'll get. Slice B is separated from the remaining pie chart because of the explode function, as we have set the explode parameter for B as 0.1. So this marks the end of this video, and that was all about Matplotlib library in Python.